This presentation is about decision theory. It's how we make decisions, but also how we explain them, which is just as important. In making decisions, we wish to make them on a rational basis. We wish to be able to explain our decisions to others. In our model, we will be making decisions with respect to data that we are using. And typically, this data will result in an action being taken. This is visually clearer when we talk about when we can use it in what's called an uncertainty matrix. Okay, this uncertainty matrix has rows and columns. The columns stand for, or here, the actual truth of the statement. Is this statement true? Is this statement false? The rows correspond to how the actions we take with respect to the statement. So whether we act the statement is true or we act as if it is false. If we act the statement is true and we act if it's true, then this is this is correct. If the statement is false but we act if it's true, that's called a type 2 error. If the statement is true but we act as if the statement is false, that is a type 1 error. And if the statement is false and we act if it's false, well, that is, of course, correct. H naught, this H sub 0, we pronounce it H naught, stands for the null hypothesis. The null hypothesis is the statement that is assumed to be true. We could be assuming it's true for rhetorical purposes, or we could be assuming it is true because it represents the current consensus of knowledge. H sub A is the alternative hypothesis, and it's simply the logical negation of the null hypothesis. Type 1 error is a mistake we made when our process leads us to acting to reject the null hypothesis when the null hypothesis is in fact true. The type 2 error is the mistake that we make when our process leads us to acting to fail to reject the null hypothesis when the null hypothesis is false. Okay. Our philosophy, we are assuming that rejecting the null hypothesis comes at a cost, such as shutting down equipment or reprinting textbooks, etc. So we do not wish to reject the null hypothesis unless it is almost certainly false. And so this leads us to significance. Significance is the probability of rejecting the null hypothesis in error. We denote the significance by the Greek letter alpha, and we wish to control alpha. That is to say, we wish to make it small.